In the silent, vast deserts of Saudi Arabia, a single rhythmic mechanical heartbeat sustains the weight of our modern, energy-dependent, and complex industrial civilization. This is Ras Tanura. It is far more than just a massive oil port. It functions as the master valve for the entire global energy grid. A mere 1% disruption at this facility doesn't just affect local oil prices, it can trigger a sudden and catastrophic global economic collapse. Welcome to the world's most critical and perhaps most fragile failure point. A place where global prosperity depends on a few square miles of sand. To see Ras Tanura is to look into the pulsing veins of the world. These pipes carry the lifeblood that fuels cities, planes, and global trade. But what happens if that pulse stops? The fragility of this system is hidden behind layers of steel and concrete, waiting for a single mistake. The impact would be felt instantly in the streets of Los Angeles, where millions of commuters rely on the steady flow of Saudi crude. In Texas, your gas price starts here. Every fluctuation in Ras Tanura's output translates directly into the dollars you spend at the pump every week. On the floor of the New York Stock Exchange, panic would set in as the realization of a supply shock ripples through the global financial markets. The connection between this desert outpost and your personal bank account is absolute, direct, and more dangerous than most people dare to imagine today. Massive tankers, the giants of the sea, move like silent ghosts away from the piers, carrying the energy that prevents the modern world from halting. History has shown us the chaos of oil shortages before. The ghosts of past crises still haunt the strategies of every modern world leader and economist. A single drop of oil here is a molecule of power. Multiplied by millions, it becomes the foundation of geopolitical influence and national security for many. This mechanical heartbeat is relentless. It operates 24 hours a day, 365 days a year, without a single moment of rest. At night, it looks like a glowing fortress of light, a testament to humanity's ability to bend nature to its will through advanced industrial engineering. But that will is being tested. The pressure within the system is reaching its limit as global demand continues to climb to unprecedented new heights. Understanding Ras Tanura is the key to understanding the modern world. It is the intersection of extreme engineering, massive wealth, and terrifying geopolitical risk. To truly understand Ras Tanura is to understand engineering at an impossible scale. Each of these storage tanks can hold over 1 million barrels of crude. The sheer volume is staggering. This complex has the capacity to export over 6 million barrels of crude oil every single day of the year. That represents nearly 7% of the entire global demand. A massive concentration of energy production that has no equal anywhere else on Earth. To achieve this, engineers had to build the Sea Islands, specialized offshore terminals located in deep waters to accommodate the largest ships in the world. These supertankers are longer than a U.S. Navy aircraft carrier, requiring deep-water berths 80 feet down to safely navigate and load their precious cargo. Every single component within this massive facility is a masterpiece of high-pressure mechanics, designed to withstand the harshest conditions of the Arabian desert. In the central control room, highly skilled engineers monitor every liter of oil, managing a network of pipes more complex than a city's subway system. The flow rates are astronomical. Systems here move 100,000 barrels every hour, pushing the limits of fluid dynamics and industrial pumping technology. Miles of silver pipelines stretch across the sand, a visible manifestation of the world's thirst for energy, connecting the wells to the waiting tankers. Automation is key. Every valve and sensor is integrated into a digital nervous system that allows for instantaneous adjustments to the global supply chain. Safety and precision are the primary mandates. When dealing with such immense pressure, even the smallest mechanical failure can lead to an industrial disaster. The loading process is a carefully choreographed dance of robotics and hydraulics, transferring millions of gallons of crude oil in a matter of hours. From the height of a ship's bridge, the scale of the operation becomes clear. You are standing on a vessel that carries billions of dollars in energy. Maintaining this infrastructure is a constant battle. Specialist teams work around the clock, welding and repairing the steel that holds back the immense pressure. The fractionation towers rise like modern cathedrals, separating the crude into the various fuels and chemicals that keep our modern industries running smoothly. It is the ultimate logistics hub, a single point of exit for a significant portion of the energy that powers the entire eastern and western hemispheres. Monitoring never stops. Surveillance drones and sensors provide a constant stream of data, ensuring that every inch of the facility remains secure and operational. The human element is the final layer of defense. These are the guardians of the global economy, making split-second decisions that affect billions of people. Against the backdrop of the desert sunset, Ras Tanura stands as a monument to human ingenuity and the sheer power of industrial civilization's ambition. But the true engineering challenge isn't just on land. Much of the infrastructure that makes this possible is hidden beneath the dark, salt-heavy waters. Expanding this capacity requires moving mountains of steel. New pipelines are constantly being laid to ensure Ras Tanura can keep up with the world. Every sensor is a sentinel. They detect the slightest change in temperature or vibration, providing the early warning needed to prevent a major system failure. The scale is simply hard to grasp without being there. It is a city of energy, a purpose-built world designed for one single task: exportation. But the real engineering battle is fought beneath the waves. The Persian Gulf is a brutal environment for any structure made of metal and steel. Here, a maze of 48-inch steel pipelines, some with walls 2 inches thick, must withstand immense external pressure and the constant threat of corrosion. A single microcrack in one of these underwater welds could escalate into a catastrophic failure, halting the flow of energy to entire continents within days. To combat the salt, engineers use cathodic protection, an electrochemical process that uses sacrificial metals to prevent the main steel pipes from rusting away. The materials used are of the highest specifications. API 5 L-grade steel is forged to handle both the internal pressure and the external environmental stress. Professional divers spend thousands of hours underwater performing manual inspections that even the most advanced robotic systems cannot yet fully replicate on their own. Using ultrasonic sensors, they see through the steel, looking for hidden flaws. Every weld must be perfect, achieving a standard that is globally recognized. Nature is a constant adversary. Marine growth can weigh down pipes and hide damage, requiring regular cleaning by specialized mechanical underwater brushing systems. The pressure at these depths is relentless. At 80 feet down, the weight of the water above adds another layer of complexity to the engineering design. These men and women are the unsung heroes of the oil industry, working in dangerous, low-visibility conditions to keep the world's heart beating steadily. Every dive is a risk, but in Ras Tanura, the risk of doing nothing is far greater, as any maintenance delay could cost billions in losses. The subsea infrastructure is a city in its own right, a complex network of manifolds, valves, and junctions that direct the flow of crude oil. Emergency response plans are practiced constantly. If a leak occurs, specialized repair sleeves can be deployed within hours to seal the breach and restore flow. It is a strange, quiet world down there. A silent battlefield where technology and human skill work together to ensure the world's energy supply remains secure. Sonar mapping provides a constant 3D view of the seabed, ensuring that shifting sands or underwater currents don't expose or damage the critical pipeline network. Everything is anchored with massive concrete blocks, designed to keep the pipeline stationary even during the most violent storms and underwater shifts in the Gulf. Back on the surface, material scientists analyze samples of metal, constantly searching for new alloys and coatings that can better survive the harsh saltwater environment. The Sea Island terminal itself is an engineering marvel, a massive artificial island that serves as the final gateway between the desert and the global market. The connection is seamless. From miles inland to miles offshore, the oil flows through a perfectly integrated system that never stops, never falters, and never sleeps. This underwater world is the foundation of our stability. Without these pipes, the modern economy would evaporate, leaving cities dark and the global trade frozen. Precision at every depth. The reliability of these subsea systems is a testament to the dedication of the engineers who build and maintain them every day. It is a journey of energy that starts deep underground, travels through the desert, and dives into the sea before reaching the world's most hungry markets. The synergy between the subsea infrastructure and the surface vessels is what makes Ras Tanura the most important energy hub on the face of the planet. This port is the single most important point in the global supply chain. When this heart skips a single beat, the entire world feels the pain. We are talking about a $2 trillion a year choke point. The value of the oil passing through this port annually exceeds the GDP of most developed nations. From high-tech plastic factories in Germany to the chemical plants of Southeast Asia, the dependence on this one single choke point is absolute and undeniable. Even the farms in Iowa are connected. The fertilizers and fuels that drive modern agriculture are often derived from the oil that flows through Ras Tanura. If Ras Tanura goes offline for even a week, your daily life changes instantly. We are not just talking about higher gas prices at the local pump. We are talking about a massive surge in inflation as the cost of transporting every single product you buy suddenly doubles or triples overnight. A sustained disruption would lead to double-digit inflation, shattering the purchasing power of the middle class and destabilizing the global economic order as we know it. The financial markets would enter a tailspin. Pension funds, retirement accounts, and national reserves are all sensitive to the stability of the global energy supply. Our modern medicine also depends on it. Thousands of pharmaceutical products rely on petrochemical feedstocks that start their journey right here in the Saudi desert. The global shipping industry would grind to a halt. 90% of global trade moves by sea, and those ships need the fuel Ras Tanura provides. Within a month of an outage, national strategic reserves would begin to fail. Countries would be forced to ration energy, leading to civil unrest and political instability. The vulnerability of our just-in-time delivery systems means that a disruption here is felt within days, not weeks, in the global supply chain. It is the ultimate bottleneck. The world has built an entire civilization around a flow of energy that passes through a few square miles of infrastructure. The domino effect is inescapable. A problem at Ras Tanura is a problem for a factory in China, a worker in Brazil, and a family in Maine. Capital flows would shift violently. Investors would flee to safe haven assets, causing currency fluctuations that could destroy the economies of developing nations in an instant. National security experts consider Ras Tanura a top-tier priority. Its protection is not just a Saudi concern, it is a global military necessity. Aviation depends on it. Without the jet fuel derived from this crude, the global skies would fall silent, isolating continents and ending the era of global travel. The wealth generated here is the foundation of global petrodollar recycling, a system that underpins the stability of the US dollar as the world's reserve currency. The pulse of Tokyo, London, and New York is synchronized with the flow of Ras Tanura. We are all passengers on this oil-powered global vessel. The paradox is that we are more dependent on this single point than ever before, despite our efforts to transition to new and different forms of energy. Even the digital world is not immune. The energy required to run data centers and manufacture chips is often tied back to the global energy market prices. Ras Tanura is the heavy lifting champion of the world. It provides the baseload energy that allows every other industry to function and grow. It is the $2 trillion choke point that holds the world hostage to its own success, a fragile link in an otherwise massive and powerful global chain. But this monumental power is also its fatal flaw. A supply chain that concentrates too much critical energy in one location is inherently and dangerously fragile. In the age of modern asymmetrical warfare, the threats have evolved. High-tech infrastructure is now a target for low-cost, highly effective drone and missile technology. Security here is obsessive, but the challenge is constant. Defenses must be perfect every single time, while an attacker only needs to be lucky once. Beyond the port lies the Strait of Hormuz, the Chokepoint's choke point. Every drop of oil from Ras Tanura must pass through this narrow and volatile waterway. The regional geopolitics are a minefield. A single miscalculation by any local power could lead to a closure of the strait, trapping the global energy supply. Then there is the silent threat, cyber warfare. A sophisticated hack into the control systems could shut down the port without firing a single physical shot. The digital nervous system that makes Ras Tanura so efficient is also a potential backdoor for those who wish to disrupt the global economic order. Constant vigilance is the only way forward. Specialized electronic warfare units work to jam and intercept signals that could be used to target the facility. On the water, heavily armed patrol boats maintain a constant perimeter, ready to respond to any surface threat that approaches the loading docks. Surface-to-air missile systems are integrated into the facility's landscape, a grim reminder of the high stakes involved in protecting the singular economic fortress. But every fortress has an Achilles heel. The concentration of so much critical infrastructure in such a small area makes it a tempting target for any adversary. The shadow of uncertainty is always present. In a world of increasing global tensions, the safety of Ras Tanura is no longer a given certainty. The desert is vast, but the target is clear. Protecting miles of pipeline from every possible angle is an almost impossible task for any security force. Satellite intelligence provides a bird's-eye view, tracking every movement in the region to provide early warning of any building threats or unusual activity. The power to shut down the world rests on a few consoles: The responsibility of the operators is immense, as a false alarm can be almost as costly as a real attack. We live in a world of interconnected risks. A political event in one corner of the globe can trigger a security crisis here within a matter of minutes. The gates of Ras Tanura are always closed to the public. It is a hidden world, a high-security zone that remains a mystery to most of the planet. Identity and access are strictly controlled. Every person who enters this facility is vetted and monitored, ensuring that the threat from within is minimized as well. The perimeter is a wall of technology. Infrared cameras and motion sensors create a digital barrier that is nearly impossible to cross without being detected instantly. The human cost of the security is high. Thousands of personnel are dedicated solely to the defense of this single point, 24 hours a day, every day. The threats are evolving faster than the defenses. As technology becomes more accessible, the risks to this centralized energy hub continue to grow and diversify. This vulnerability is the dark side of efficiency. By creating the world's most perfect energy port, we have also created its most dangerous single point of failure. Ras Tanura is a massive economic fortress, but in an uncertain world, no fortress is ever truly invincible against the changing tides of history and conflict. Ras Tanura is a testament to human ingenuity, but it is also a stark and constant reminder of our collective vulnerability in a modern age. In a world desperate for energy transition, this massive paradox remains a heavy burden we must all carry together as we move toward the future. The question is no longer if the system will change, but when and how we will manage the transition without breaking the world we have built. Ras Tanura, the fragile giant at the heart of our world. Thank you for watching this deep dive into the $2 trillion choke point holding the world.